Good morning. Welcome to another session on environmental impact assessment.
So we shall continue with Unit 3, Air Quality, Noise, Energy, Water Quality, Vegetation and Wildlife Impact. Course outcome, apply the knowledge of the impact of infrastructure project on air quality, water quality, vegetation and wildlife. Learning outcome, EIA for noise pollution. Specific outcome, step-by-step procedure to perform the EIA for noise pollution. So till now we have seen air pollution, EIA for air pollution, then we have seen about noise pollution in the last session, and this is EIA for noise pollution. So the 6-step activity model for EIA studies. Step 1, identification of the noise impacts of proposed project. Step 2, preparation of description of existing noise environmental conditions. Step 3, procurement of relevant noise standards and or guidelines. Step 4, impact prediction. Step 5, assessment of impact significance. Step 6, identification and incorporation of mitigation measures. And the last step, preparation of final environmental impact statement. So identification of noise impacts. So the first step in the methodology is to determine the potential impacts of the proposed project or activity on the noise environment. So this requires identification of noise levels associated with the project. A considerable body of information exists on noise levels associated with a variety of projects and related activities. The sources of noises are numerous, so they can be broadly classified into two categories, industrial and non-industrial. The industrial category may include noises from various industries like transportation, vehicular movements, rockets, defense equipments, and explosions. Among the non-industrial category, the notable sources of noise uh, are from loudspeakers, traffic, aircrafts, trains, construction works, radios, TVs, vacuum cleaners, mixers, power lawn mowers, and air conditioners in the domestic or commercial usage. Construction activities generally generate noise levels in excess of those typically found in the project environments. Uh, Construction sites can be categorized into four major types. First one, domestic housing including residences from one to several families. Second one is non-residential buildings including offices, public buildings, hotels, hospitals, and schools. Third one is industrial buildings including religious and recreation centers, stores, and repair facilities. And the last one is public works including roads, streets, water mains, and sewers. Noise from construction of major civil works such as dams gently affect relatively few people other than those employed at or near construction sites. So these sites are not included in these categories. Generally, dams are located uh, on the outskirts of the city, so you don't have many people living over there. So that does not come under any of these categories. Noise from project operations includes sound emissions from highway vehicles, aircrafts, recreational vehicles, internal combustion engines, and industrial machinery. Noise produced by highway vehicles can be attributed to three major generating systems. One is rolling stock, such as tires and gearing. Second one, propulsion systems related to engine and other accessories. And the third one is aerodynamic and body systems. Step 2, description of existing noise environmental conditions. So in analyzing the potential noise impacts of a proposed project or activity, it is necessary to consider the study as the area associated with the noise emissions, right? So the area is the project area or the area of influence. The delineation of a study area can be made based upon the boundaries of the land associated with the project, or the delineation can include a larger area by considering the area of noise influence within the vicinity of the proposed project. Vicinity means which is in the neighborhoods, right? So you can delineate the study area based on the boundaries, or delineation can include a larger area by considering the area of noise that is influencing the vicinity of the proposed project, meaning people nearby the project area getting affected, right? So that is the vicinity of the proposed project. So if no specific data on existing noise levels is available for the study area, it might be possible to use published noise level information developed for project involving similar land use. So when you don't have any data, you can possibly use some of the published noise level information developed for this project, uh, not developed for this project, developed for projects involving similar land use pattern. Third one is procurement of relevant noise standards and our guidelines. So the primary source of information on noise standards, criteria, and policies uh, will be the relevant local, state, and federal agencies which have a mandate for overseeing the noise environment of the study area. Additional information will be available from international agencies such as World Health Organization or the United Nations Environmental Program. This information can be used to determine the baseline quality and the significance of noise impacts incurred during projects. It could also aid in deciding between alternative actions or in assessing the need for mitigation measures for a given alternative. The maximum perceivable sound level at a worker's ears and the time of exposure are not related directly to the noise produced by any one machine but depends upon the total noise in the area where the workers are located with respect to the machine and other factors. For this reason, noise emission standards or their intent must be confined to product noise emission regulations. Basic noise levels for industrial zones should not exceed 55 decibels at night and 65 decibels during the daytime. Noise results in cardiovascular problems like heart diseases and high blood pressure. Workers exposed to high noise levels have acute circulatory problems, cardiac disturbances, neurosensory and motor impairment, and even social conflicts at home and at work can also take place. So this is you know noise exposure limits for various work environments, right? So for example, you have 85 decibels of noise, so it can be heard for about 16 hours, right? You can be exposed to 16 hours of 85 decibels noise, nothing will happen to you. 87 decibels, 12 hours 6 minutes. You cannot expose a person more than that to 87 decibels. 90 decibels 8 hours, 93 decibels 5 hours 18 minutes, 96 decibels 3 hours 30 minutes, 99 decibels 2 hours 18 minutes, 102 decibels 1.5 hours, 105 decibels 1 hour, and the remaining all of them are less than 1 hour, right? See, if you see 130 decibels is very high noise, you can expose yourself only to 1 minute to such noise. If you do that more than 1 minute, you will lose your ability to hear. So this is another table showing the noise zone classification for different zones. What is the noise exposure class, and uh, uh, there are some parameters which are prescribed over there, and we are not going to get into those parameters. So you should just know that this is a noise zone classification chart. Step 4 is impact prediction. One method of expressing both existing noise and predicted noise levels is by using a level weighted population value. So the assumptions that the intensity of population response is one of the several consequences of average sound level depending upon the response mode of interest, and that the impact of high noise levels on a small number of people is equivalent to the impact of lower noise levels on large number of people in an overall evaluation. Based on these assumptions, the fractional impact can be determined as a product of sound level weighting value and the number of persons exposed to the specific sound level. Summing the fractional impacts over the entire population provides the sound level weighted population, right? So it is sound level weighted population, also called as LWP. So LWP is actually calculated based on population distribution function, based on day and night average sound level weighting function, characterizing the severity of the impact as a function of sound level, and DLN is nothing but the differential change in daylight or differential change in daylight day night average sound level, not daylight, it's day night average sound level. So it's a differential change in day night average sound level. Assessment of impact significance is step 5. Step 6 is mitigation measures. Mitigation measures refers to steps that can be taken to minimize the magnitude of the detrimental noise impacts. The key approach to mitigation is to reduce or control the noise expected to be emitted from the project. Mitigation can proceed along three possible courses of action, either by changing the source or by changing the path of the noise from the source to the receiver, or you can change the receiver who is receiving the noise. Some additional principles on noise control, including the reduction of the number of vibrating sources, enclosure of the resources, and attenuation noise by absorbing barrier methods, are also important, right? So these are some principles of noise control which we have not dealt directly in this session, but it is important for you to know these things. Step 7 is prediction of the final impact statement. So the final environmental impact statement should include summary tables and discussion with industries. The results of analysis will help in decision making. Maps should show location of surface receptors and measurement rates and size balance. Thank you.
Thus, we come to the end of this session. Thank you for your participation. Looking forward to meeting you in the next session.